In this chapter, we're going to look at a very common operation on an RDD, and that's called a reduce. So where are we? Well, previously we set up one of these RDDs. Now, albeit it's a very basic data set with a massive 4 items. As I mentioned though, we can very easily switch this data set for a properly massive data set, and we'll be looking at how to do that a little bit later on. For now, this little bit of test data will suffice. Now, what I want to show you in this chapter is one of the fundamental operations on an RDD, and that's called a reduce. You might be familiar with this already, maybe from working in Hadoop or working in just general functional programming, such as using Java 8 lambdas. So if you are familiar with this already, then you can safely skip this chapter. If you're not familiar with it, then this chapter should be a great introduction. I'll try to keep things nice and straightforward, and I'll assume that you don't have a lot of experience of using Java 8 lambdas. Now, a reduce is used when we want to perform an operation against an RDD, which is going to transform a big data set, like our massive 4 items here, into a single answer. So we are going to be crunching down a big data set into a single answer. So for example, a nice obvious one would be, let's say we want to sum up all the values in this collection. Well, actually we want to sum up the values that's contained inside the resulting RDD. Now, if it were a normal Java collection, we could of course just loop around this input data, have a total, keep adding to the total, and at the end of the loop, real simple, we've got our total. Ridiculously trivial stuff. But of course, we're going to be working in a massive data set where our data is going to be spread across multiple nodes in a cluster. Well, of course, here on this picture, I'm heavily simplifying, but it's very similar to the picture we used in the introduction. I'm showing here that we have a data set spread across 3 nodes somehow. Actually, I've just randomly scattered the values around. Now, we can't just iterate around this collection because it's spread across multiple JVMs, multiple physical computers. So the way reduce works is that we define a function of some kind, and this function is the reduce function. Now, for a summation, the reduce function is going to be very simple. It's just going to be take a value and add it to another value. Now, it might not be obvious to you exactly how this works across this cluster. What happens is the driver, and remember that's the virtual machine that's actually running this program, is capable of sending that function across to each partition. And now each partition is going to be free to execute this function against just that partition. So let's take our node 1 as an example. So we've got some values in this partition, and we know now that this function has been sent across to this partition. Now, what happens in a reduce is that this function is applied to any 2 values in the collection. So we could take, for example, it doesn't matter which of the values we take, but we could, for example, take the first element, that number 7, as being value 1, and the second element, value 4, as being value 2. But crucially, we could have picked any of the values because a reduce must be able to be done in any order. So we can use any of the values for value 1 and any of the values for value 2. In a reduce, there will always be a value 1 and a value 2. And now all that happens, it's incredibly simple. The function is applied to those 2 values. Now, we determined that what we want to happen is we want the values to be added together. But this function could be anything. It could be arbitrarily complex. So all that's going to happen here is the 2 values will be added together, in this case to give the value 11. And now we're left with 3 values on this node. And now the reduce simply continues. Spark will nominate any 2 values to be value 1 and value 2. In this case, it's picked the 9 and the 13, and it applies the function to those 2 values. So that's going to give us a 22, and it continues. Well, because we've only got two values left, then one of them will become value 1, one of them will become value 2. The function is applied, and for this node, we've reduced the problem down to the simple answer of 33. Now, presumably in parallel, the same process will have been happening on node 2 and on node 3. So we happen to have reduced down to the answers 18 on node 2 and 18 on node 3. That's just a coincidence from the random values that when I built the caption. Now, once the reduce has been applied to all of the individual nodes, the next step is that in this case, the three answers are gathered together onto a single node. Now, I'm being very imprecise there. We will be talking in a lot of detail about how Spark does shuffling later on in the course at some point in this series, but for now it's not really important which node this is going to happen on. But I hope you can see that the three subtotals, if you like, that came from the three nodes are now gathered together in the same place, and Spark will now run another reduce. It will nominate any two of these to be value 1 and value 2, and it'll apply the function. So we get 51, and it continues until there's just a single number. So just once more, another value 1, another value 2, apply the function, and we now finally have the answer, in this case 69. So I hope you don't mind me going through that in such detail. It is a very simple process, but it's so fundamental to working with big data that really I thought I ought to really expand on it and elaborate. But how do we do that in the code? Well, it depends on whether you've done Java 8 lambdas. I hope if you are new to lambdas that what I'm about to do will feel fairly natural and straightforward. So I want to repeat what I was doing on the captions. So I have an RDD and I would like to do a reduce on that RDD. Now remember that RDD is distributed across multiple partitions, probably across multiple physical nodes. But to us here in the driver program, we don't need to worry about that. We can simply call the reduce method. Now, probably shouldn't surprise you that there is a function called reduce on the RDD. Now, this is where things get a little bit complicated. Now, if you're reading the IntelliSense there, it's telling us that we need to pass in a parameter of type function2, which has a generic of a double, and a double. Again, there's full details of this on our Java Advanced course, but I'll turn this into English for you. It's telling us that we need to pass in as a parameter the function that we want to be the reducing function. We want to write a function that takes any two values and adds them together. To turn this into English, it's saying we need to supply a function which takes two input parameters and they're of type double, and the function must return an answer again of type double. And by the way, this is something that I haven't mentioned with the reduce function. One of the restrictions of the reduce function is that the return type of the function needs to be the same type as the input types. If you need to do something where the return type is different, then you need to do something other than a reduce. But that's okay for us, of course. Given any two values, if we add them together, we'll still have a double as the answer. Now, I think that's enough theory. I'm just going to dive in and show you how we express a function as a parameter in Java 8 and above. It'll turn out we don't actually need them, but it might make it clearer. If I use these curly brackets here, I'm going to put inside the curly brackets my reducing function. And the syntax of the function is we have round brackets, and inside those round brackets we're going to declare the input parameters. And then after the round brackets we have, I'm not sure what the symbol is called, it's an arrow really, it's a dash followed by a greater than sign. And then we continue with the implementation of this function. Now again, we can work from the caption. The function is going to be taking a value 1 and a value 2, and it needs to add them together. So in these round brackets, we declare that the function is going to call the two input parameters value 1 and value 2. We could have called those anything we like. And then the implementation of this function will be to take value 1 and add it to value 2. Now I just put those curly brackets in just for illustration, just to show you that I'm trying to get across here that this is a block of code that we want to send to the partitions in the RDD. Well, it won't compile with those in place, so if I take those out, I hope you can see now that I don't have any red squiggles. This is now valid Java code. I must admit I do this kind of thing in other languages, but as a long-standing Java programmer, to me this still feels a little bit unnatural in Java. You might be wondering, for example, how does it know what the types of value 1 and value 2 are? Surely we should have to declare them. Double value 1, double value 2. And yeah, you can absolutely do that if you want to. But because Java knows that this RDD is working on objects of type double, it knows that the values in the RDD are doubles already, so these types can be inferred. And you're going to find in Java 8 it's quite natural to not include the types here because we know what the types are. We know that the end result of a reduce, even if we've got 1,000 partitions and it's had to do lots of different reducers which it's then combined together, we know the end result is going to be an answer, which will be of type, well, it's going to be a double. Now we're going to find as we go a little further with Spark that it can be quite difficult when you're doing some complex operations here. It can be quite difficult to work out, well, what is the return type going to be? We can kind of work it out by hovering over the reduce, and the IntelliSense is telling us that this reduce, yeah, it takes this complicated function as an input, but the output is going to be of type, and that's here, it is going to be of type double. So that's one way you can work out what the return type is going to be. Anyway, more on that later when we get more complicated, but for now, let's just print out the results. So a very simple program, but our first reduce. Let's give this a run. Now watch out for this, the program has run. I can't see any output apart from this logging, and I will explain what this stage 0 is a bit later on. But I can't see my answer, and I think that's just because if I expand the console, yeah, watch out for this. This red text is actually being output to the error stream, even though it's not an error. And the system out is this here in black, and sometimes, quite often actually, they get interwoven and you'll find they're not kind of neatly aligned. But I hope you're happy with that. Of course, I could have probably done that a lot quicker on a calculator, but we'll be scaling all of this up later, and you'll be having a good chance at practicing with reducers for yourself quite a lot in this course. I hope you're happy for now with the principle of reducers. In the next chapter, we'll look at how to work with mapping operations.